Now let us solve few sums based on a GP. Here is the first question. For a GP, A is 7, R is 1 by 3, find T6. So that means we are given the first term, the common ratio, and we have to find the sixth term. Right. Now here we know the basic formula to calculate any nth term of a GP. It is nothing but A into R raised to n minus 1. So therefore, putting in the values, we have T6 equal to A is nothing but 7 and multiplied with R is 1 by 3 raised to 6 minus 1, which is n minus 1. So that turns out to be 7 into 1 by 3 whole raised to 5. So that is nothing but 7 upon 3 raised to 5, which is 243. So therefore the answer is 7 upon 243. Now let's go to the next question. For a sequence, Tn is given by 2 raised to n minus 2 upon 5 raised to n minus 3. Show that it is a GP. Now here to show that a particular sequence, say T1, T2, T3 up to Tn is a GP, then it means that we have to show that for any pair of consecutive terms the ratio is constant, because that's the definition of GP. So let's consider the general term Tn, and the term before that is, as we know, nothing but Tn minus 1. So if we show that the ratio of these two terms is constant, that is, it does not depend on n, then it will prove that the given sequence is a GP. Right? So therefore let us do the ratio of Tn and Tn minus 1. Now putting in the given expression, that is, for Tn we have 2 raised to n minus 2 whole upon 5 raised to n minus 3. This is Tn. It has to be divided with Tn minus 1. So wherever there is n, we will replace it with n minus 1. So which will give us 2 raised to n minus 1 minus 2 whole upon 5 raised to n minus 1 upon 3. Right? So moving further, this gives us 2 raised to n minus 2 upon 5 raised to n minus 3, and the expression which is in the denominator, we will flip it and write as the denominator will go to the numerator, that is, it will become 5 raised to n minus 4, because n minus 1 minus 3 is n minus 4, and in the denominator we have 2 raised to n minus 3. Right? So therefore let's club the terms which have 2 as the base and write them in the numerator. So what happens is 2 raised to n minus 2, and from that the degree in the denominator gets subtracted, that is, n minus 3 will get subtracted, divided by, let's do clubbing of the terms which have base as 5 and write them in denominator. So here it will be 5 raised to n minus 3 minus n minus 4. So this in turn gives us, we'll see that n will get cancelled, and minus 2 plus 3, which gives us 1. So that is 2 raised to 1 whole divided by, in the denominator also n will get cancelled when we open the bracket, and minus 3 plus 4 gives us once again 1. So that turns out to be 5 raised to 1, which is nothing but just 2 by 5. So we have shown that the ratio of any term to the previous term is 2 by 5, which is a pure constant. It does not depend on n. So it does not matter which ratio we take, it is going to be a constant term. Therefore the given sequence is a GP. Right. Now let's go ahead to the next sum. Find the three numbers in GP such that their sum is 35 and product is 1000. Now we have seen how to assume the three numbers which are in AP, and since we are given the product of those three numbers, it will be good to assume the three numbers as A upon R, A and AR. Right? Because when we use the condition of product, when we take the product of all these, which is given to be 1000, we will see that R gets cancelled. So we have A cube equal to 1000, which readily gives us A to be equal to 10. Now let us use the other condition, which is related with their sum to be 35. So therefore, adding those numbers, we have A by R plus A plus AR equal to 35. Now A is 10, which we have just found. So substituting that, we get 10 upon R plus 10 plus 10R is equal to 35. So now we can take 10 common from all, and we have 10 multiplied in the bracket. We have 1 upon R plus 1 plus R equal to 35. Right? Now we can cancel 5 from both sides, and what we are left with is 2 and 7. Right? And then we also merge the terms inside the bracket, and we'll get the common expression as 1 plus R square whole divided by R, which is equal to 7 by 2. Right? Now when you cross multiply and simplify, we will get a quadratic equation, that is 2 into R square minus 5R plus 2 is equal to 0. And on solving this quadratic equation, we get the two values of R as either 2 or 1 by 2. Alright. So now let us see. We have the middle number A, which we have already discovered that it is 10. Now if the ratio we consider as 2, common ratio is 2, then the first term will become 5 and the second term will become 10 into 2, which is 20. Right. Now if the ratio is 1 by 2, we will get merely the same terms but in the decreasing order. So therefore in that case, the first term will become 20, the second term will become 10, and the last term is nothing but 5. So therefore basically the three required numbers are nothing but 5, 10 and 20, which is the answer.